Assalamu alaikum. Let's continue today. So, this part is about debugging and the concept of debugging operates at three levels. First is the standard Python breakpoints, logging, profiling, memory. Then there's the second layer, the tensor operations, shapes, types, devices, nan and int values. And then there's third level, training dynamics, loss curve, gradient, and estimation. Now this is about the debugging thing. I think I should open the Git repository as well so I could see the actual code. So there's the phases, setup and tooling. And then there is the part for debugging and profiling. And then there's the code and debug tools. So this is basically in Python. Oh, no, it is lot. This is a lot. Well, import time, etc. So let's start writing it. Alright, let's see. I am going to create a new folder here called debugging. It's going to be inside of this. Great. Now inside it, I need to create a debug tools.py, and let's do this. Print debugging gets dismissed. It shouldn't. For tensor code, a targeted print statement beats stepping through a debugger because we need to see shapes, D types, and value range. I don't understand shapes and D types correctly, so I will look them up. What are shapes and D types in AI or that's it? Fundamental properties of a tensor. What is a tensor now? A mathematical object data structure used to represent multi-dimensional arrays of numbers. Okay, I see 3 plus is a tensor. I know about matrices, I know about vector, I know about scalar. Okay, so above 3 dimensions there is tensor. A 3 dimension is a tensor and more is also called a tensor. Okay. Now, what is a shape? Shape determines the dimension and the size of the tensor, describing how many elements exist along each axis. So it represents layout or box holding the data. This is the empty tuple. This is the 1D vector, 2D vector, 3D, and 4D. So in simple one line, what is a shape? It is the dimension dimensions of a tensor. That's it. I think. Is shape the dimension of a tensor? Yes, shape are describe the dimensions of the tensor. 1D vector array of numbers, 2D vectors, and 3D, 4D known as a batch. It is a D type data type. Okay. Exact kind of data stored in the tensor. So the F floating point 32, floating point 16, BF16. I do not about BF16. And the integer 32, int 64, int data. Okay, so D stands for data types. It can be integer, decimal, or boolean. What is BF16 data type? BF16 data type is a brain floating 16-bit floating point data type developed by Google Brain. It is widely used in artificial intelligence and deep learning. BF16 provides the same broad dynamic range as the 32-bit float point, but occupies half the memory, accelerating model training, reducing hardware requirements. Game changer for AI. While both they divide bits significantly, it has 10 mantissa bits. Mantissa is after the decimal, I'm pretty sure. Is mantissa part after the decimal point? So mantissa is after the decimal, or 45 is after, okay. Then BF16 has 7 mantissa bits, which means it's slightly less precise, but it assigns more bits to the scale. Okay. I understand. So D type and shape. Shape represents dimensions, and the D type represents the data type, which is floating point instance. Def, debug, print, name, tensor, print. Okay, name, shape, tensor dot shape. When I'm typing this, I could copy paste. I could copy paste this, but I guess I should practice some more Python. I haven't done it in a long time really. Dtype is equal to tensor dot dtype. Okay. No, then I have to print more. I don't have to close it right away. Okay, then a comma. And there's f device equal to the tensor. So device, it's PC device. F device then f min equal to the tensor dot min for item. And this is a 4 this truncates it to 4 floating point right? Pretty sure. That's done now. Max equals tensor dot max and item and dot 4f. Okay. Now what else is there? F mean. Mean is equal to the tensor dot mean dot item and to 4 floating point values. Then F has nan equal tensor dot is nan dot any dot items I has nan is nan any items. It tells me if there are nans in there. Okay, let's continue. Call this after every suspicious operation when the bug is found. Remove the prints. Simple. Call this after every suspicious operation when the bug is found. Remove the prints. Simple. Okay. Python debugger. Def training step. Okay. Def training step. Model batch criterion optimize. A batch is a 4 dimension, right? There is batch. What is batch in console? A group of multiple data samples like images grouped together and processed simultaneously. Multiple data samples that are processed simultaneously are called a batch. If you process a single color image, your tensor shape must be channeled height and width. When processing a batch of images, the tensor shape becomes batch size, channels height and width. Okay. A grayscale image is 22 by 20. A batch of 32 of these images has a tensor shape of 32, 28. Okay, basically it increases in one dimension, and the second and third dimension represents the width and height. The first one represents the size of the pixel. Okay, now what is this? Inputs labels equal to the batch and outputs equal to the model inputs. So these are the inputs and the labels essentially. But no, 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 I don't have to put this here. No, that was wrong. Actually, I have to put this in Python. Criterion outputs labels, and if loss, I should close this. If loss item greater than 100 or torch dot is nan loss breakpoint import torch. So I'm importing torches. They I have they imported torch as well. They are not imported torch. Oh no, they have. Okay, this is a different type of importing way. Import torch dot nnsnn has storage true except has storage false. I guess I would put this here. Import torch. Okay, let's continue. This is the breakpoint. This is loss backward optimizer dot step. So what is training step? It takes the batch. From the batch, it takes the inputs and the label. Okay, and then it outputs equal the model inputs. It puts the inputs into the model and gets the outputs. Loss, it gets the loss based on the criteria. Then if loss item is greater than 100 for torch.isNamed loss is not a number, breakpoint. It has a breakpoint. Okay. Loss. um, All the system breakpoint or system breakpoint must accept whatever arguments are passed. By default, this drops you into the PEDB debugger. Okay, so it drops me into the debugger. Right. Output.shape. This. One thing I want to know is how does this work? Let's say I do thing is equal or okay, thing is equal to 1, 2, and 3. Unexpected indentation. Alright, thing is equal to 1, 2, and 3. Now if I do input output is equal to thing, what does this do? Too many values to unpack. Expected 2, guard 3. So I cannot do this. So batch has only 2 dimensions in this case. Okay. This is condition you only stop when something looks on for 10,000 step training run that matters. Replace print statements with logging when your debugging goes beyond a quick check. So import logging and and I have to logging basic config. I do not know about this. I have never used this. So copy paste login. So I'm missing some things. Loss item. Should I put this inside of that? Loss spike detector. Where have they put this? So this is somewhere else. Logger info and info. Demo delogging. Uh, logger dot info. So it's in demo logging somewhere. So demo logging. I could just copy paste, but I guess I'm going to copy paste this. No, that's a demo. I need to actually, I just do this. I need to put this here. No, still no. I just am going to stop this for now. Login info start training LR percentage dot 4. I don't know what that means, but okay. You want a log file, not terminal output that scrolls off the screen. Okay. I guess this makes the this is a logging file. This logs the output to a file in the current directory name. Timing code sections. So import time, and I can place a class of timer. Let's make this class right now. Okay, class timer that this is basically the constructor for the class, and by default it is nothing self.name equal to the name, and that enter self self.start equals time dot ref counter. But I want to know what is this enter and exit. I have not done this in Python before, so I will look this up. Oh, it's automatically generated this, so I don't want this. Args elapse full time dot per minus self dot start print f okay self dot name and elapse for f and s. Okay, so it subtracts the current time from the previous time to get the total time passed. What is enter and exit in Python? What is this? Are special or magic dunder methods that they power the with statement allowing you to automatically allocate and release resources. It handles the setup, it runs before the code inside the with block executes, and this handles the cleanup. It returns after the with block finishes, even if the code crashes or raises an exception. Okay, so with timer data loading batch is equal to next. This is called a timer is not defined, but I defined the timer right. So it's outside. Okay, so it's outside. How have they written this? Demo conditional breakpoint, device checking. They have wrote this. How have they wrote this? What was it called? This was called timer. So I could just type timer here to the timer. Okay, so def demo training. So this demonstrates a demo training. Let me just copy paste this to see what it is. Okay, let's call this method and let's see how it is. So this will create a timer object with a name, and this will on the start when the due to the with keyword when it starts it makes a variable called start, and then it makes a variable called elapsed. On the exit, it subtracts them and then prints out the total seconds that have passed. So keyboard interrupt, CD phases, tooling, and debugging. I need to source from this, and it's sourcing now Python debug tools for Python. Let's see what it does. So matrix multiply in this amount of seconds. The battery does go out faster than recording. Okay, so this matrix multiply. Okay, great. Now let's move on a bit more. Part 5. See profile and common finding area. I have to read this first. Data loading takes 60% of training time. The fix is num workers is greater than 0, not a faster GPU. So number of workers that act on the data greater than 0. C profile and line profiler. Python-MC profile dash S cum term cumulative time trained with Viva. Okay, let's see Python-MC profile S cumulative time trained dot Viva. Is this an actual thing? Okay. Uh, what does this mean? I don't know, maybe. Command Python, and I can do dash M dash M module link. Such as the spot for the name module runs the corresponding profile as a script. This terminates the option list. Following options are passed arguments to the module. So if I want to run a custom module in the command line, then I have to do this. And these are the different areas. This is a Boolean page actually. What is C profile? Man C profile. This is possible man Python and C profile. Not found, whatever. Okay. C profile. This shows every function call sorted by the cumulative time for line by line profiling. I have to do uv pip install line profiler. So this is going to install the line profiler. Not great. And I can do this. I don't know about this add profile method annotation. I do not know about this at all. What this is. F. What is F? Is it some sort of import? Okay, so they have used train step F. So F dot cross. No, where is it? Then? What is this? Detect and check devices, check gradients, blah blah blah. Where is the actual thing that train step line profile? I do not know about this. Output model loss backwards run with turn drop turn drop. That's a thing. Timer unit. Yeah. Memory profiling. Trace malloc. So malloc is used for I know it is used for. Is there a quick fix for this? I don't know about this. But maybe I should look it up. Line profiler. Line profiler. Okay. So how does this work? Third party install line profiler. Import time and heavy computation. So execute with current prop. Okay, so basically any function that I want to run, for example, debug print, let's say, but let's see demo time. I want to run this function. I do current prop hl dash v this, and this will give me the entire profile. Timer units. Okay. Does it make an output? It makes an output. Training log. No training log. I prop this is either binary or underscore to text accordingly. If I open it anywhere, or whatever. Analyze the output. Okay. But why was it not showing me what was happening? Oh, maybe I have to do add profile on top. Profile. Why is this thing? Profile. Is it fixed? No, no, it's not fixed. The import time you have profile. I'm doing it. If I just do quick fix, ignore, suppress the environment. Now, what is it going to do? Is this actually going to work? Okay, so it's now working. So the problem was with Thailand's. It was causing the problem. Okay, let's move forward with this. Memory profiling, how much is there? I'm not sure. I think this will take me 2 days. Then import trace malloc and start your code here. Model build, load model, take snapshots. Okay, I think I should just read this one now. How much memory this CPU memory with memory profiler profile loads the data, loads the data. Line by line memory usage. When you hit OOM out of memory, use CUDA empty cache to free cached memory. Dell Tensor. Mixed precision. Common AI bugs and how to catch. The most frequent bug, a tensor has sheer batch frequencies when the model expects bad channels height and width. This is the most common bug. So a tensor has the shape of badge and big features. So the problem is the model has badge and all of these. Features are the inputs I'm pretty sure. Feature are features inputs in machine learning or AI in general. As features are the inputs to machine learning. This is just fancy names. Check the shape, do this. I'm going to just copy paste this method here. Sample input shape, then make the hook. Name modules, modeled or name modules. Okay, in shape, out shape, return the hook. Okay, return the hook dot append, make hook model edge dot. Okay, Run this one with a simple batch. It maps every shape transformation in your. Okay, so shape mismatch. I should do this. It takes the model. It takes the put puts the in shape is in what is in now. Model will name modules. For every single module, what does it do? Hook store append module will register forward hook make hook name. And makes the hook of the name. What is the name? Name and module of the model. Now, okay, for every module, it makes a hook. Then what does it do? Using the module, um, what does this do? Isn't that a function inside a function? Why is it? I don't get it. Oh, it generates a hook. I understand. It makes a function that is inside the array. Okay, with torch, no gradient module sample input. Okay, I don't understand this fully, but I get the gist of it. It's making a function. It's making a hook for the entire model idea. No, it is. What's it doing? What is it doing? What is it doing? Um, it's basically for the module is taking the input shape and producing the output shape. Okay, now what else? Null loss meaning something exploded. Some common causes are learning rate too high, division by zero, log of zero, negative numbers, exploding gradients in R and N. What are R and N's? I have forgotten, or maybe I have not learned it at all. R and N's stand for random neural network. Recurrent neural is a specialized type of neural network designed to process sequential data such as speech, text, and time series. It handles inputs independently. RNN processes data step by step, looping information from one previous steps back into the network, allowing them to understand the context of the entire sequence rather than a single data input. They have long-term memory and they have short-term memory. Okay. Reply not necessary. Okay. Designed to process sequence such as text. Okay. Sequential data, it has a memory unit, so it remembers and processes it over and over again. Hidden layer, okay. CNN, I should please see this infographic. Where is the infographic? Where is the thing? Yes, here. Convolution, you feed forward using filter putting, pooling, pooling. Size of input is allowed for us. So the size of input and the resulting output are fixed, receives images of fixed size and outputs them to the appropriate category along with the confidence level of its prediction. May vary. Outputs and inputs are fixed. Okay, the size may vary. And more or fewer words. Spatial data such as images. The temporal sequence such as text or video. Image recognition and classification, face detection, text translation. Okay, so recurrent neural networks are used when there's some sequence like videos in which they sequence the images. It needs to remember the previous thing as well to generate an output. Okay, data leakage. Torch dot is nan loss at step case. For name frame, modulo named frames, standard red is not none. is nan parent or grad or any known grade is integer. So it checks the gradient of the parameter, meaning the input. So if it explodes or produces zero, then it logs it. I'm correct. I need some confirmation. So this function gets the gradient of the parameter into the in the model and tells if it's int or nan, right? Validating the concept. Yes, validate. Please. Yes, you're right, but one important condition. You're summary, but you missed the very first trigger. Success. It starts by evaluating the overall loss. Triggers on nan loss only if the loss is nan, not a number. Does it proceed to check the gradient? If it's fine, then the function skips the gradient check altogether. Okay, I understand. It checks value with the gradient tensors either known or unknown. The model accuracy on test sounds great. It's a bug. Your model gets 99% accuracy. It's a bug. Why? Now what's the problem? Data train set has set train ID, set train ID column to list, and it gets the test set to list overlaps. What does overlap? Length of overlapping in both sets. So basically the problem is if the test and train data is too similar, there's a major overlap, then there will be data leakage, I guess. Meaning there will be a very high accuracy. Wrong device, check the device tensor or the car's runtime, but sometimes the tensor silently stays on CPU while everything is training just slows down. So to check for devices, check device model and tensor. What is this? What is this? This is the pointer. Model dot parameters dot device. Where is this next function? I do not know all of it. Then there's IT enumerate tensors volume tensor model not equal to the model device. Okay, tensor board basic shows you what's happening inside training over time. Okay, this is the part A. Alright, let's continue from where we left off and let's just continue. Okay, so I was at this part, I'm pretty sure. Check devices button. This was the tensor board basics. I need to sort my this now. UV pip install tensor board. I do not know about this at all, but let's do this. So I have to import a summary writer, but I don't understand. Okay, why am I installing it in the environment? I should just install it globally. But for some reason, Arch doesn't allow that. So I'll just have to do this. Tools dot TensorBoard import summary writer. If is it non-existent? I guess it's non-existent. Doesn't exist. Summary writer tensor. I guess it's gone. Summary writer. No, I guess it still exists. I'm just not typing it correctly. Summary writing. Let me just copy and paste. It says that there is no summary writing. Quick fix. I guess I could ignore it. If I ignore it, will it still work Python? Okay, first I have to go to setup tooling and debugging Python debug tools or debug. Okay, it's not a fun. Did you forget to import profile, profile, import profile? Okay, profile. Just delete this. Okay, so it is working. The summary writer. It's just not. Um, it just Highlands doesn't know it's there essentially. So that's part of the problem. Training over time for steps and range. Do this. Log their equal runs. So I guess I will do this. How did they write it? It's a method for summary writer. I will search for writer over here. No, summary writer. But they have not made it for some reason. Loss not decreasing, learning rate too low, or model architecture issue. Loss oscillating wildly. So learning rate is too high. Loss goes to man. Numerical instability, then there's train loss decreasing, val loss increasing, weight histogram collapsing to zero, vanishing gradients and gradient histogram exploding. Okay, so before run, check shapes with a simple batch, verify inputs and outputs. Hence, print tensor dot print shape. Actually, whatever tensor I put in here is going to log the shapes that, and I don't have a model. Okay, A3 section modify dummy model to introduce a name. Okay, so I guess I could make debug practice py, copy this entire code in here, and oh, forgot, control D, control shift. I did not this. What is wrong? Control shift V, control V, no, what? Okay, so I guess I'll copy this entire thing manually. So, and I, okay, copy and paste. Now this is done. Now run debug to read section, modify the dummy model to dummy model model. Okay, so where this is the dummy model. No, this is not dummy. What is this? Check shapes. This is the dummy model. Okay, this is the dummy demo check shapes. Is there no dummy here or something? Dummy? No. Shapes. It's there. What else? No, it's model. Here, here, here. Okay, I don't understand this one. Let's go to the model. Where is it? Where is the dummy model? Okay, here it is. Checking shape checklist for the model. This is the NAND detection. I found it. First, let me run it properly. Debug practice. Okay. It's checking the shape NAND detection. NAND lost NAND and NAND lost direction at step 99. NAND detected. Well, it already has a NAND. I don't understand. Profile C profile. So Python dash M Python dash M C profile cumulative time and debug practice. So now I have to okay, I have to go look for the slowest function here. Why isn't it scrolling up and down? Okay, this is annoying. So this the terminal just explodes and it doesn't show me what's the problem. So I could do electricity dot, otherwise I'll just go to projects. And this is debugging and source is send this to Python and debug practice. Debug. Much better. Okay, so there is quite a large file. Okay, just a bit more, just a bit more. How big is this? Come on, I might as well just scroll up. Come on, how big is this? Okay, I got type this to less. Okay, great. Image tracking and detection. Cumulative time. So this is the slowest function. Initializing. How to identify the slowest function with C profile. I guess the top. Okay, my Wi-Fi is on for some reason. I will disconnect and reconnect. So I think the top function is the smallest one because it sorts in descending order, perhaps. Okay. This all of us run this work with generate the start profile. Pay attention to the origin. That's all from the function. At the top of the call select will have a very high cumulative time. So essentially, The init method and the debug practice.py, the entire file. What is the function that is causing this problem? The rest of them are fine, I guess. Okay, but I understand now how it works. Trace malloc to find which line in the data allocates the most memory. Do I have trace malloc? Trace malloc. So they told me to use trace malloc somewhere here. I need to know where it is. There it is. Memory profile. No, this is memory profile. Trace malloc. CPU memory with trace malloc. Okay. CPU memory with memory profiler. So can I do this? Okay, this is another. Why is it doing that? Come on. Because it was full screen, that is the problem. Okay, so essentially all I have to do is wait a minute. Okay. Uh, so Python dash m memory profiler debug practice. Is that how? No module in memory profile. Okay. I guess I just run this normally and it will tell me the most memory allocated. Memory tracking 884 bytes average. So where is the trace malloc? Trace malloc, trace malloc. There it is. Trace malloc start. Okay, so this is memory profiling. Let me see. So memory tracking. It's just showing the entire file. And showing 132 line number 132, which is this. This is has this is using the most amount of memory. Set up TensorBoard for simple training run identify. TensorBoard. Okay, I guess I have to set up TensorBoard now. Okay, from torch.utils TensorBoard import summary right. Okay, now writer is equal to summary writer. How do I make this go away? Maybe I should do dev environment. Maybe I should set this up because I kind of went over it in a high. Like I was like, I don't need it that much, but yeah, perhaps I should set it if it tells me about these codes. It does not. It does not tell me about it. Well, but this, I'm sure this one did somewhere. There was some JSON for targets right here. VS Code launch. I could just do quick fix, ignore, type ignore. Okay, so I have to do TensorFlow for simple training and identify whether the model is overfitting. First step in range loss train model batch. Where is the actual model? Well, the model is present in which function? It is present, I guess, right there. There are two models. What is this? Yes, I have to check this one. So I have made the writer. I have made the semi-writer. I want it to be runs um, runs the experiments on the model. Here is the model. I do for step in range num steps. What are num steps? What is this? This is not even defined. I don't understand how to use this. The step in range number of steps. What is number of steps? I could do tensor board. How do I use this? How do I use this? How do I use this? Okay. Load TensorFlow notebook with import TensorFlow STF, remove the logs, data set example, normalize, etc. I don't understand. So it's creating a model, then what's it doing? Model compile on the callback, model fit, start TensorBoard. The tools interface is generally use the. Okay, so I don't know about this. I don't understand how to use this essentially. TensorBoard log here runs an experiment. How do they run it? TensorBoard log there equals runs. So it's running on my local host server. Localhost 600 localhost 600. You haven't written data to the event files. If you are new to one, you want to find out how to edit it. TensorBoard tutorial. Yes. TensorBoard remove the logs, create a data set. Um, but what are they doing? They're doing it so differently. I don't get it. For example, the tensor board, board, board. They are not using it themselves, so I don't have an example on how to use this. So let's continue with the next. We use breakpoint inside a training loop, practice inspecting tensor shapes and gradients from the debugger prompt. So something like I go to the model model. So I could do breakpoints right here, and let's start this, and let's see. Okay, so it launches me straight into the debugger. And the thing is, I don't know how to use the Python debugger. I could just use this right here, debug file. So I don't know. Well, that's it for today, I guess. Standardized protocol is interesting. I do not know how to use TensorBoard. That's the problem. I guess I'll research on this on my own, and I'll continue later. For example, for now, I'll just commit to my git. Okay, see you all later.